right, we're now looking at target 1C.3, and it says I can identify an expression as rational or irrational by adding and subtracting radical numbers to simplify. Okay? So just some rules that we have is if you're adding two rationals together, you will always get a rational number. If you're adding two irrationals together, you will always get another irrational number, almost. There's one exception in cases where you're subtracting like something and then like the opposite of that thing. So if I have like square root 3 minus square root 3, just like 3 minus 3 is 0, the square root of 3 minus the square root of 3, those are opposites, and that equals 0. So there's the exception is when they're opposites. It doesn't just happen with like the square root of 3 and square root of 3. It could be square root of 10, square root minus square root 10, right? Anything where one's positive, one's negative, right? You're going to get that 0. Okay? And 0 is a rational number. It's an integer. And then a rational plus an irrational is always irrational. Okay? So for the most part, when you're adding, most of the cases we're going to see are irrational, but you do have to be careful of that when they're the same, but opposite. So we add or subtract the following radical expressions, then determine whether your answer is rational or irrational. With these, it's very similar to combining like terms. If they have the same square root, you can combine them. Okay? So this is a square root 6 and a square root 6. So all we're doing is we're taking 5 plus 3 square root 6, right? Which is 8 square root 6. Then this, right, it has a square root. I cannot simplify the square root of 6, right? It does not give me an integer. So this is irrational. Looking at our next one, same thing with subtraction, right? Both of these have square root 5s. They have the same square root. So we're doing 7 minus 2 square root 5. And 7 minus 2 is 5 square root 5. Okay. Again, this has a square root, and a square root makes it irrational. Be careful when there's no number in front, just like before, right? These are both square root 11s. But when there's no number in front, there is a 1 there. Okay. So we have 1 plus 1 square root 11, and 1 plus 1 is 2 square root 11. And again, it has a rational, or it has a square root that doesn't simplify. It is irrational. Looking at our next one, they are all square root 7s. There's 3 of them, so we have to combine all 3. So I'm going to take the 8, right, the 1, and the 2. So that's 8 minus 1 plus 2 square root 7. Again, 8 minus 1 is 7. 7 plus 2 is 9. So that's 9 square root 7. And like all the ones before, it is irrational. Looking at example 5, 5 and then the 4th root of 6 minus 8, the 4th root of 6, plus just square root of 6. Okay? These are the same. This one is not, right? because these have that fourth root there and this one doesn't. So I can only combine the 5 minus 8 with the fourth root of 6. And then plus our square root 6 just gets tacked on at the end. So then 5 minus 8 is negative 3, fourth root of 6, plus the square root of 6. Okay. Ooh. And there's a lot of things here that we cannot simplify. I'm going to write it over here. So this is irrational. Again, square roots left in your problem make it irrational. 5 square root 3 plus 2 square root 5 plus square root 3. If you look, these are the same. This is different. It has that 5. So I'm only going to combine 5 plus 1. Plus 2 square root 5. 5 plus 1 is 6 square root 3 plus 2 square root 5. And same thing, this answer is irrational. Example 7, 3 plus square root 7. If you look, this one doesn't have a radical at all. This one does. They're still not the same. I can't actually do anything here, okay? This is just the answer. It does not change. So if you can't combine anything, your answer is just exactly what that is, okay? So 3 plus square root 7, and then that is same thing, it's irrational. Because we do have a square root in the answer that doesn't simplify. And that's it. Go ahead, work on C3.